let's look at an application problem. So this is we call the related rates. Let me use a different color. Okay, if I need to name, but the name is not really important. Right. So before we solve a problem, we have to carefully read the problem. Never ever try to solve a problem when you don't even know what the problem is asking for. So this is very important. Okay, so here it says the volume, okay, given by this equation, of an expanding cube is increasing at the constant rate of 120 cubic inches per second. Okay, so V stands for the volume. How fast is the length S of each side? So now we know what S stands for. It's the length of the side, okay, increasing when the volume is 8 cubic inches. So it will always be very helpful that when you read the question, you want to know what is given, what is the thing that you want to find. Okay? So first of all, you're given an equation, V equals x cubed. This is the equation for finding the volume of a cube. And you know that dV dt is equal to the constant 120. How do you know that? It tells you that this volume is increasing at the rate of 120. Okay, so when we talk about the rate or rate of change, it means derivative. Okay, and from the question you can see that this cube is expanding, so therefore the volume is expanding. So what does that mean? That means you treat the V as a function of t. The length of the side of the length, the length of the side is also a function of t. Okay, it does not say that, but from the description, you know that these two quantities, the volume and length of the side, they both change as time changes. So the rate of change for the volume is equal to 120. All right. So what are you looking for then? How fast? So that's another key word. Fast means rate of change, like how slow, how fast is talking about rate of change. How fast is the length S of each side increasing when the volume is equal to 8? So you are looking for the rate of change for the S. Okay? When volume is equal to 8. So now we have converted a word problem into a more like a math problem. You have something given and you have something that you are looking for. Okay? So here you first treat V as a function of t, S as a function of t. We have done that. 2. If you differentiate both sides of the equation, with respect to t, then you get this. So on the left hand side, you have dv dt. On the right hand side, this is a composite function. Okay, so s is s of t, and then you take the cube power, the third power of s. So this is 3s squared times ds dt. So that's what you get. All right. So now set dv dt equal to 120. Why? Because that's the given information. So you have dv dt equals 3s squared times ds dt. This is the formula you get from step 2, equals 120. All right. And so now you can see that you get an equation that involves ds dt, and ds dt is the term that you are looking for. But you're not looking for ds dt in general. You are only looking for ds dt when the volume is equal to 8. So for find the s when v is equal to 8. Well, so because v is equal to s cubed and this is equal to 8, this implies that s is equal to the cubic root of 8, and that is equal to 2. Okay, so now if we go back to this formula, 3 is a fixed number. We know that at the moment when the volume is equal to 8, s should equal 2. And then something that we're looking for, and this equals 120. So now 5 plug s into the equation. Which equation? This equation, and solve for ds dt. Okay, so what do we get? We get 3 times 2 squared times ds dt is equal to 120. So 3 times 4 is equal to 12. Simplify this a little, we get ds dt is equal to 10. Okay, so let's review this framework a little bit. Very important, never ever try to solve a problem without carefully reading the problem. When you read the problem, you try to find the structure, what is given, what is you are looking for, and try to use mathematical notation. Volume is equal to length of the side to the power 3. The volume is expanding at the rate of 120. So dv dt, this dv dt means the rate of change of the volume, and it says the rate of change is equal to 120. So that's why I have this equation here. How fast tells you you're looking for a derivative. Okay, what derivative? Derivative for what? Derivative of the length s, because it's how fast is s increasing, basically, right? So we're looking for ds dt, but only ds dt when the volume is equal to 8. So only when the volume is equal to 8. All right. So take the equation that you have, keep in mind that both the variables v and s, they mean function of t. Okay. To create the dv dt and ds dt, you need to differentiate the equation you have. Okay, and when you differentiate this equation you have to keep in mind that you are thinking v as v of t, s as s of t. Okay, so when you treat both v and s as a function of t, then the left hand side will be dv dt. The right hand side, you apply the chain rule, derivative s cubed. A cubic function is 3s squared times the derivative of the inner function. The inner function is s of t. So you don't know what it is, you should write it as ds dt. Okay, so now you use the information dv dt equals 120. So that tells you the part 3s squared times ds dt equals 120. And you are trying to extract the number ds dt from that equation. Okay, but you still have a missing piece, that is the s value. So you use the last piece of information, which is this. You are looking for the derivative when v is equal to 8. So when v is equal to 8, you realize s is equal to 2. Plug that 2 into the equation, you can easily find that ds dt is equal to 10. So it's like this. Okay.